Hello, today our regular Friday updates about AIs, and we have a lot of updates today. And also today is a Groundhog Day, so happy Groundhog Day. And we start with code Llama 70B. So in August, Meta, Facebook, released code Llama, which is a variation of their Llama model. It's open source, and it's trained to work with code. And they released 7 billion parameters, 13B and 34B. Now they updated them and they added a new model, which is 70B. And according to all the tests, this is the best model in existence so far for working for code. So this is some comparisons, and you see the numbers. I mean, it's very impressive. So they outperform. Even 34 was outperforming some major models, and yeah, it was on par of Codex. But 70B is bigger and better. So model is available. You can download it and from Meta, from Hugging Face. So you can run full model here. This is the instruction. You can run it locally using Llama on your computer. Run locally in VS Code using Cody and Llama. I'll talk about it later. And yeah, this is how you can use it here from Hugging Face chat. By the way, this is what I use all the time, the huggingface.co /chat. I usually use Mistral. They have two versions of Mistral there, and they have code Llama. Very, very handy. Okay, LLM for coding, DeepSeek-Coder. This is another model, also very good, and supports more than 80 programming languages. You see, pre-trained on 2 trillion tokens. I mean, this is a lot of effort in building those models. Another model is WizardCoder. Okay, this is SQLCoder, default SQLCoder. So it's open source, GitHub, and you see the results of testing, and it's by far the best. So you see GPT-4 accuracy 82%, and here it's 93%. So it's really the best model to make SQLs. So you tell it what you want to get, and it gives you SQL. Okay, this is cody.dev. Really, really simple to use. Highly recommend. By default, it uses chat GPT, I mean OpenAI via API. So if you have it, it will just use it, but you can also tell it to use some other model. So for example, it can use, in this particular presentation in YouTube, he's using code Llama 7B locally, 7B code, which is fine-tuned for working with code. And it's really easy. So this is a picture from my VS Code, and you just search for Kodi, you find Kodi AI, you install it, and then I recommend just follow this video where he goes through steps how to install it and run it. So you can ask it to complete your code. You can ask it to write code, to verify, to create documentation, like create the tests for your code. It's very, very good. Why it's here? Let me remove it. Okay. So next, another similar application is called continue.dev. And again, you can, it's an extension for VS Code, and you can use it with a whole bunch of different models, including via API and local models. And yeah, it also code base as a context, so it knows your code. So if you're sitting in the middle of the code, it understands what it needs to do. And yeah, so this is another very good one. There are multiple leaderboards which compare models for coding, and so you can check them out. And I really, at this point, I really want to compare like code Llama 70B instruct with DeepSeek, with OpenAI Codex, although it's probably much better than Codex. Google DeepMind Alpha Code, they announced it in December, Google, and they claim that it's the best, but there's no way to run it anywhere. I'm not aware. There is also Salesforce CodeGen, and apparently CodeLlama is much better than CodeGen. So yeah, you probably just take CodeLlama and work with it. Google Bard upgrades. I love Google Bard. This is actually recently my one of two models which I mostly use. I either go to Bard or I go to Mistral in Hugging Face chat. And recently it became better. So first of all, they changed the underlying model. It used to be Palm, I think, or Lambda, not sure which one, but now it's Gemini Pro, the latest version. They added multimodality, so now it can make pictures. So here I asked create an image of a seahorse riding on the top of the car, and it created two images for me. So it's included. It just works. It uses this new model called Imagen 2. They're adding some other features like conversational search to Google Maps, and they're working with music. But overall, my personal experience with Bard is getting much better. People say that maybe because Bard also somehow works with Google search and it is aware of recent events, but it's really, really useful. So I enjoy using it. Okay, Rabbit R1, this is this device which was sold through many months forward till I think May or June. So it's a 200 device with can help you to do operations like place orders, or like whatever. It has a large action model. You can train it to do operations. It's good, but what apparently it doesn't run these models locally on the device. In fact, the CPU, like the hardware of the device is cheap, like you probably cost less than $100. And although now they're not charging for subscription, but the model actually running on the servers. So it's kind of like using ChatGPT or other models which are available via browser. But here they're available via this device. It has a small screen, but mostly you just talk to it. Um, they made a deal with Perplexity, so they will provide. Perplexity is charging for their service, so eventually it will be a subscription model. And yeah, this is about Rabbit R1. Sam Altman collecting investors to build AI chips. So there will be factories which are making chips for OpenAI. This is a very good conversation, a really, really good interview with Sam Altman. He's talking that models are getting smarter, access to training data becomes a problem, right? Synthetic data, regulations, politics, election security, support for military. OpenAI is growing. It's already about 800 people. Censorship in different countries, global standards. GPTs may be customized down to a government level and even down to a user. So there was a conversation that in some countries they are against AI and how you go through that. So it's a very interesting conversation. Now about Meta. So as you know, Meta is releasing their models in open source, and they actually explain why they're doing this. And this is from a recent phone call where this is Mark Zuckerberg talking and explaining why they're doing it. Apparently, it's better for the company long term. It's already profitable for them, and this is the 100% the long-term strategy. Jan LeCun was talking about this for like many times, and yeah, they're spending a lot of money to buying hardware. They open sourcing everything, new data centers, custom chips, not just standard H100s for AI inference, because their goal is to serve hundreds of millions of users using AI tools. So AI serving AI services is becoming a huge industry just to work in production, right? Okay, next, I want to make some parallel with Linux versus Unix. I remember end of 90s where everywhere there was Unixes, and there are multiple Unixes. So this is the diagram of this zoo of different Unixes. This is Linux. This is from Wikipedia, by the way. There's a history of Unix. Everything else are other Unixes. And nowadays you probably don't use them, well, unless it's a Mac or it's Android or something, or iPhone. Like everything else mostly disappeared. So you see what happened. It took, well, about 10 years for open source to take over. So the same is absolutely the same is happening with AI. And there are major players like Meta, Llama models, and other models they produce, and also Mistral. And Mistral CEO was talking about it, and he was making the same parallel. He is saying that it always happens that open source wins. It wins eventually, and it cannot be stopped. So that's just to understand. Now, there was a lot of commotion about this model, MiQ70. So somebody put it on Hugging Face, and people started running it, and they realized it's a really, really great model. It's better than Llama. It's on the level of GPT-4. So what the hell is it? And eventually, Arthur Mensch, who is the CEO of Mistral, explained what it is. So this model is actually from September. When they released the Mistral 7B, they also trained model 70B, the bigger model. And what they have done, they took Llama 70B. So look, this is Llama 70B and this is Miku 70B. And these are parameters of the model, like the hidden size, the intermediate size, number of heads, number of hidden layers. You see, it's the same thing, right? So what they did, they took Llama model and they retrained it on their data using their methodologies. And what they received is a model which is much better than Llama. And what he is saying that we've made good progress since, so stay tuned. And yeah, we're staying tuned because they promised that they will release open source model which will be better than GPT-4. So we're definitely waiting for it. Next, ollama-python and ollama-js. So this is really cool. Maybe I should just let me demonstrate it really fast. So let's say I go into IPython and I take this code, import ollama, create a stream with a question, and then process the stream on the output. And let's go. And it's not running, of course. Oh no, it's running. Okay, good. So you see, it gives me the answer. So the question was why sky is blue, and it gave me the answer: Earth atmosphere, relay scattering. So yeah, it works. So you can use models from your Python or from your JavaScript code. It's very, very easy to do. Like in Python, just pip install a Llama, and that's it. And npm install a Llama in JavaScript, right? Okay, next is Jan.ai. This is open source project which gives you application to run on your computer, laptop or desktop. It may be Windows, Mac or Linux, and it's completely open source. And this is a great project, and they have a roadmap. A lot of things will happen. It already great project as is. So yeah, you probably can and should start using it. Mamba Hermes 2.8 billion parameters. In December, there was a regional paper which introduced Mamba. Just a reminder, all large language models using attention mechanism. They use transformer architecture, and the attention mechanism has attention matrices n by n. So this is a quadratic complexity because of those matrices. So people tried to somehow come up with the architecture that doesn't have this quadratic complexity. And Mamba looks like it's a really, really great approach. And since then, there were a whole bunch of publications on arXiv. using Mamba architecture for different purposes. And this Mamba Hermes, so it's open source, and yeah, and you can use it. Open source Mamba model fine-tuned on Open Hermes dataset, and you see, and pip install torch transformers, so on. Because Mamba is not a transformer, you need to run original Python code using torch library. That's kind of the only limitation, but this is great. You can run it on your computer. Next, embeddings and ColBERT. So this is interesting. Suppose you're doing some sort of a RAG system. So you have documents which you convert into vectors, and then you have your query, your question, which you also convert to a vector, and then you do similarity comparison, similarity search to find documents which more closely match your question. This is typical RAG. But in ColBERT, they're doing it a little bit differently. They create embeddings from tokens, individual tokens which are in the document and individual tokens which are in the query. Then they match them together, they calculate the sum on like a token by token comparison. There are benefits for this because there is a limited number of tokens. The vocabulary of tokens is about 30,000. So it's a small vocabulary, and it's a very technical work. You convert into tokens, and then you match them, how many matches you have, and then you just summarize and you get the score, how well query matches the document. But it's also very mechanical. You're basically matching keywords or key tokens. You are not matching the meaning. Like you cannot really deal with synonyms or like whole phrases. So it very efficient, but at the same time, it's not really good when you need question answering, summarization, or text classification. But it's very fast, very efficient, very good for matching for like a big scale. So that's why people use it. Okay, this is a very interesting map I found. This website is informationisbeautiful.net. And you see it's year by year, starting from 2020, 21, 22, 23. So we're here, and this is the size of the model, and the diameters are the sizes of the model. So you see the bigger models are here, the smaller models are here. I love, and if you go to this link, it's actually interactive. You can click on it. It's kind of animated. It's fun, but it's not really complete. It doesn't even have Mistral or Mixtral, so you cannot really trust it. But still, you see how many different models. And the great thing that you can use small models like 7B, which are here, and you see there are a lot of them. Like actually, if you go on Hugging Face, you'll see there are thousands of models. Anyway, AI as a baby. So we have Mama Humanity, which talks to baby and so happy that the baby says Mama, Papa. Well, of course, it hallucinates. Like, so we have multiple kindergartens which train those babies to speak. So this is approximately where we are. Okay, LLM is primitive as a worm. So this is how modern LLM is working. You have input where we encode the text into vectors, then they go through multiple layers of transform architecture. At the end, we generate the next token, add it to the input, and continue this process. So it's really, really simple. It's really similar to a regular worm, right? But if you look at some real systems, like for example, brain or internal organs, or this is a car engine, you see it contains multiple different parts, different shapes, different functionality, connected in some ugly asymmetrical ways. And what probably will happen, and already happening, that people now start using multi-agent systems. So for example, you have LLM writer, and it writes, but it starts hallucinating, and it doesn't even know that it's hallucinating. But you can use additional LLMs with a task to verify what this writer is doing and maybe correct, and they communicate. And people now creating multi-agent systems with multiple agents communicating, helping each other, verifying, validating, and so on, formatting. And this is a very fast developing area of multi-agent systems. How quantized 4-bit models run? So you know that the models are big, like let's say Llama is well, 70 billion parameters. Each parameter is 2 bytes, so we're talking about 140 gigabytes. So you need at least two 80 gigabyte video cards to run it. So it's expensive hardware. But you can quantize it down from 16-bit per number to 4-bit per number, and then suddenly it becomes much smaller and you can run it on a laptop. I mean, you still need a lot of memory, but then the question is how you actually do multiplications if you have 4-bit. And people do it in different ways. Usually they convert to higher precision just before they're doing arithmetic. So full conversion to higher precision, either to 16-bit or 32-bit, or maybe to 8-bit. It depends. There may be partial conversion with scaling. So what you do, for example, you do multiplications at a lower bitness, and if you have higher, you may have a bigger number, so you need to scale it down to fit in a smaller bitness. There is also direct multiplication if hardware allows it. So maybe you don't need to do conversion, you can just do it directly if hardware supports it. Okay, now question, how people actually do quantization? Well, one way is like very naive. You just look at your numbers, you find the maximum absolute value. So maximum of absolute value of your data. This is, let's say, M, maximum. And let's say you want 8-bit. So 127 divided by your maximum, this will be coefficient, and then you multiply all your data on this coefficient, and then it will fit in minus 127 to 127. So now you can store it in 8 bits, right? This is a naive way, not very good way to do it. A better way is do naive quantile quantization. So what you do, you take all your numbers, you sort them, and you divide them into groups of same number of points in each one of them. And then you assign a number depending on which part they landed, right? So, well, this is a reasonable way to quantize, but it is slow because every time you have to find you have to sort and you have to find those separation levels between them. So what people do in practice, they predefined those quantiles, these groups, usually using Gaussian distribution. So this is Gaussian distribution, and we divide it in pieces so that the areas are the same. So you see, like area of this is the same as area of this, is the same as area of this, and so on. So here you have 16 of them. So this gives you quantiles, and then that's how you store it. And then you don't do math in this form. You only use it for storage. When you want to actually use it for arithmetic, you have to dequantize it. So the model is stored in quantized version, but then all arithmetic is done in a dequantized version. Another thing to understand is that the vectors themselves, like when you convert tokens into vectors inside the model, like here on the input, they actually probably, well, not probably, but usually in like 16-bit so they are not quantized down, and as they propagate through the architecture, they still stay not quantized. So only the weights are quantized, and they are dequantized to do the arithmetic. Okay, why do large language models hallucinate? So this is a simple explanation. So LLM predicts the next token, as we know, and it does it based on statistics of training data. So it doesn't have brain, it doesn't understand what it's doing, it doesn't have judgment. If the right data was not available in the training data, or if the training data was noisy, so LLM will try to predict something, to select something from the data it has from the training, and it can make a mistake, and it, because of the noise or because it was not present there, it will start generating something else. It will just generate the token which has the highest probability from what it has statistically from the training, right? And it may be completely wrong, and it has no idea what it's doing. Well, it's doing its job, right? It generates the next token. So this is hallucination. LLM doesn't understand. It simply follows contextual patterns, the probabilities. So good prompts may help to avoid hallucinations. You can also use separate LLM agents which will validate the outputs, and you can use RAG systems and so on. So there's a lot of work in this direction. Attention, facilitation, and inhibition. So in the brain, in nervous system, there are two mechanisms, facilitation and inhibition. Neurons that fire together wire together. This is a quote from Donald Hebb from 1949. So this is about the brain. So this is called facilitation and describes how brain pathways are formed and reinforced through repetition. So this is the basis of learning, basically, right? Facilitation. Another mechanism is lateral inhibition. So if you have a very bright point, like everything around it seems black, right? So you have inhibition. So the combination of this facilitation and inhibition, these are like two basic mechanisms which brain uses for learning. And when we're thinking about attention matrix, it's kind of the same thing. We're trying to find words which support each other, and then we're using softmax, a function, to suppress everything else and non-linearly. And that's kind of what brains are doing. I just wanted to make this parallel. Okay, there are some other small news and updates. So there is a browser at u.com. It was announced that it will be a default browser on iPhones in Europe. So this is how it looks. You can go to u.com and check it out. There are a couple of links. These are about prompts. As you know, I provided before a lot of good guides how to do prompting. So these are two more very good ones. This work is very interesting. Jan.ai.org. So they not only they release the model in open source, but they also release the data, the procedures, the intermediate results, the checkpoints, like the whole thing. So completely transparent. Yeah, this is a little bit sad news. Nicholas Wirth has died. He was almost 90 years old, and it's something very dear to my heart because he's the guy who created Algol and Pascal, and I worked with Pascal a lot when I was younger, and this is a great language. Anyway, he lived in Europe and Switzerland. Oh, this is an interesting tweet. This is hilarious, in fact. So this guy trained a bot to swipe on Tinder profiles for dating based on his preferences, and then used ChatGPT to message them to set up dates. He communicated with more than 5,000 women, and 1 year later, he engaged with one of them after ChatGPT actually suggested that he proposed. This is absolutely hilarious. Neuralink implants chip in the first human brain. Open source Mistral Miku nearing GPT-4 performance. Chinese model now It actually at the same level as GPT-4 and beats in some categories. And there are 100 congressional offices already using AI. Okay, this is layoffs. Some people are concerned that maybe AI will uh, cause layoffs. It doesn't seem like it's happening. So this is by year. We see 2020, 21, 22, and here at the beginning of 23 there was a lot of layoffs. You see, and then it kind of went down. So we're here. So there are some layoffs, but not too many. And you see there is a SAP, 8,000 people, about 7%. PayPal, Microsoft, about 2,000 people, Unity, Wayfair, and so on. Google laid off 1,000 people, eBay. Uh, but I think it's more restructuring because Google, like I use Google Home, and my understanding is that this part of their business they kind of squeezing down. They're not interested in it, and I'm pretty sure that they're very big on AI, as we all know. And anyway, so the situation is not very bad. Now, this is Hugging Face Leaderboard. So things are changing, but again, I'm not trusting them. So you see that precision, these are all full precision model, and some models are big, 70 billion parameters. There are several which are like 13 billion parameters. Okay, this unfortunately was not changed. Let me check. Maybe it has changed. Just as, no, it's January 26. So this is crowdsourced arena. So it still shows that Bard is on the second place. And look here, the statistics was very small. Like, look, there are 30,000, 18,000. For Bard, it was only 3,000. So it was recently added, but it was already statistically valid that it's on this place. So this is great. And this is Mistral. This is the best open source model so far. These are some other leaderboards, and we're done for today. Thank you.